Hollywood has painted a thrilling but often inaccurate picture of our universe. From epic space battles with roaring engines to astronauts freezing solid in an instant, we have been fed a steady diet of cosmic fiction. This journey will dismantle 30 of the most stubborn space myths, replacing sci-fi fantasy with hard scientific truth. You will walk away with a completely new and accurate understanding of how the cosmos truly operates. We will uncover why you cannot see the Great Wall from orbit and what really happens to an unprotected human in the vacuum. Are you ready to have everything you thought you knew about space turned upside down? One of the most persistent cosmic falsehoods claims the Great Wall of China stands as the only human structure visible from the edge of our world. This idea likely gained traction from old-school textbooks and speculative writings long before we ever left the planet. The reality, confirmed by countless astronauts who have actually been there, is far more humbling. From low Earth orbit, the wall is incredibly difficult to spot with the naked eye. Think about what you are actually trying to see. The wall is roughly the same color and texture as the soil and rock surrounding it. Its width, while massive up close, is equivalent to trying to spot a single human hair from nearly 20 miles away. Without high-powered zoom lenses or specific camera equipment, it simply blends into the mountainous terrain. The truly visible markers of human civilization from that vantage point are not ancient stone walls, but sprawling, brightly lit cities at night, or the vast, dark geometric shapes of major agricultural fields. The myth of the Great Wall's visibility crumbles under the simple, stark facts of scale and perception. This same confusion of perspective gives rise to another famous cosmic misunderstanding, the idea of a permanent dark side of the moon. We often hear about the mysterious far side, a place forever shrouded in shadow and secrecy, but this is a complete misnomer. The truth is, there is no part of the moon that is in permanent darkness. The correct term is the far side, the hemisphere we from Earth can never see. This phenomenon is called tidal locking. Billions of years of Earth's gravitational pull have slowed the moon's spin to a perfect sync with its orbit around our planet. It takes the moon about 27 days to complete one rotation on its axis, and the exact same amount of time to complete one orbit around Earth. Because of this matched rhythm, we are forever looking at the same familiar face. Think of it like walking in a circle around a friend while always facing them. You complete a full circle and you also spin around once yourself, but your friend never sees your back. That is the moon's relationship with Earth. Yet during that long lunar day, which lasts about 2 Earth weeks, sunlight sweeps across every single inch of the lunar surface. The far side experiences a brilliant 2-week-long sunrise, noon, and sunset, just as the near side does. It is not a land of eternal night, but a landscape that basks in the sun's light while turned away from our view. So when you look up at the full moon, remember there is an entire other world, fully illuminated, just waiting on the other side. Our own eyes deceive us every single day with the color of our nearest star. From Earth's surface, we watch the sun rise and set in brilliant shades of orange and yellow, painting the sky with its warm glow. This daily spectacle has cemented in our minds the idea of a yellow sun. But this is an illusion, a beautiful trick played by our own planet. The sun, when viewed from the void of space, is objectively, scientifically white. So why the dramatic difference? The answer lies in our atmosphere. Sunlight is composed of every color of the rainbow, a perfect blend that creates white light. As this light travels through the thick layer of air surrounding our planet, the gases and particles scatter the shorter blue and violet wavelengths. This scattering is why our sky appears blue during the day. It filters out those cooler tones, leaving the longer red and yellow wavelengths to dominate the light that finally reaches our eyes. At sunrise and sunset, when the sunlight passes through an even thicker slice of atmosphere, this effect intensifies, creating those stunning fiery hues. The sun itself has not changed, only our perception of it through this planetary lens. Astronauts on the International Space Station confirm this, looking out their windows to see a star that is a stark, brilliant white. Scientifically, our sun is classified as a G-type main sequence star, a category often informally called yellow dwarfs. This name is a bit of a misnomer, based more on its position on the color spectrum relative to hotter blue stars and cooler red stars than its actual visual appearance. If you could place it next to a pure white light source in a controlled environment, you would see its light is essentially white with just the faintest hint of yellow. This white light is the true, unfiltered energy that powers our world, a constant and dazzling nuclear furnace whose real color is hidden in plain sight. That brilliant white sun in the vacuum of space holds another secret that shatters a classic movie moment. We have all seen the terrifying scene: an astronaut's suit tears and they instantly flash freeze into a human popsicle. This is perhaps one of the most dramatic and scientifically inaccurate tropes in all of science fiction. The reality of exposure to space is far stranger and more horrifying because you would not freeze solid right away. In fact, the vacuum of space would keep you surprisingly warm, at least for a little while. The reason lies in a fundamental difference in how heat works. Here on Earth, we lose heat quickly through a process called convection, where air molecules carry thermal energy away from our skin. But space is a vacuum, an almost perfect emptiness with no air, no water, no molecules to steal your warmth. Without that medium, the only way to lose heat is through the much slower process of radiation, where your body gradually emits infrared energy. In the shade, this would eventually cause you to freeze, but it would take hours, not seconds. Your own metabolic heat would keep you conscious and painfully aware for a considerable time. So what would actually happen in those first critical moments without a suit? The immediate danger is not the cold, but the lack of atmospheric pressure. The fluid on the surface of your eyes, tongue, and in your soft tissues would begin to boil, a gruesome process called ebullition. This is not boiling from heat, but from the sudden, drastic drop in pressure. Your body would swell to perhaps twice its normal size, though your tough skin would likely hold you together. All the while, the real clock is ticking on the oxygen stored in your blood. Within 15 seconds, you would use up the oxygen in your bloodstream and lose consciousness. The ultimate cause of death would be suffocation, a silent, chilling end in the vast, insulating emptiness. The cold of space would claim you last long after you are gone. That same insulating vacuum that would slowly steal your warmth also creates a profound and permanent silence. Think of every epic space battle you have ever watched, the roar of starship engines and the thunderous blasts of laser cannons. In reality, those scenes would be utterly, unnervingly mute. Sound, as we experience it, is a mechanical wave. It needs something to travel through, a substance whose molecules can bump into each other, creating a chain reaction of compressions and rarefactions that eventually reaches our ears. Here on Earth, that substance is our atmosphere, but space is a near-perfect vacuum, an emptiness with so few particles that there is no medium for sound to propagate. An exploding star, a colossal event that rips a sun apart, would make no noise at all in the void. So why does science fiction get this so consistently wrong? The answer is simple: drama. A silent explosion on screen, no matter how visually spectacular, feels strangely hollow and less impactful to us as viewers. Filmmakers add those iconic rumbles and crashes because our brains are wired to expect sound from violent, energetic events. It connects us emotionally to the action. But science has found a fascinating workaround to listen to the cosmos. While there are no sound waves, space is filled with magnetic and electric fields. These fields can cause clouds of charged particles, known as plasma, to vibrate. These vibrations are not sound, but they are waves of energy that can be recorded by scientific instruments. Scientists can then take the data from these plasma waves and mathematically convert it, shifting the frequencies down into a range that human ears can hear. It is a form of data sonification. What we get is not the sound of space as if we were standing there, but a translation, a haunting chorus of pops, whistles, and wails that represent the invisible forces shaping the universe. These translated sounds from planets like Jupiter or the Sun itself give us a completely new auditory way to study these celestial bodies, revealing patterns and activities that might be missed by the eye alone. The cosmos may be silent, but it is far from quiet if you know how to listen. Black holes are not the all-consuming monsters of science fiction. The terrifying image of a black hole as a cosmic vacuum cleaner, sucking in everything from nearby stars to distant galaxies, is a profound misunderstanding of how gravity truly works. A black hole's gravity is not some magical, infinitely powerful force. It obeys the same universal laws as any other massive object. Think of our own sun. Its immense gravity holds the entire solar system in place, yet Mercury, Venus, Earth, and Mars all orbit it perfectly safely without being pulled in and destroyed. A black hole is simply a region of space where matter has been compressed into an unimaginably dense point, creating a gravitational field so strong that not even light can escape from a certain boundary. This boundary is the event horizon, the point of no return. It is not a physical surface but a mathematical threshold. Outside of this boundary, the physics is entirely normal. Stars, gas, and dust can orbit a black hole for billions of years in a stable dance, just as planets orbit our sun. This is visibly demonstrated by the stars orbiting the supermassive black hole at the center of our own Milky Way galaxy. They whip around it at incredible speeds, yet they remain perfectly intact, held in a gravitational embrace but never crossing that fatal line. What often creates the dramatic visuals we see are accretion disks. When a star or a cloud of gas ventures too close, it can be torn apart by tidal forces, its material stretched into a swirling, superheated disk that spirals inward. This process is not a simple suction. It is a violent, chaotic transfer of matter that generates immense light and radiation, making the black hole's presence known. But an object that maintains a respectful distance, just like our planet with the sun, would continue its orbit indefinitely, completely untouched by the darkness at the center. Another story that sounds clever but falls apart under scrutiny involves a simple writing instrument. You have probably heard the tale that during the space race, NASA spent millions of dollars developing a pen that could write in zero gravity, while the Soviet cosmonauts simply used a pencil. It is a perfect parable about over-engineering and simple genius, but it is almost entirely fiction. The truth is far more practical and reveals a shared problem both space programs had to solve. In the early days, both American astronauts and Soviet cosmonauts did indeed use pencils, but they quickly discovered a terrifying flaw. Pencil lead is made of graphite, a form of carbon that is highly conductive. When you write with a pencil, tiny flakes of this conductive graphite dust break off and float into the weightless cabin air. In a spacecraft filled with sophisticated, sensitive electronics and an oxygen-rich atmosphere, this floating dust presented a catastrophic fire hazard and a severe risk of short-circuiting vital systems. The humble pencil, it turned out, was a hidden danger. The solution was not a whimsical choice, but a critical engineering requirement for safety. Both space programs moved away from pencils and began using specially designed pressurized pens. The famous Fisher space pen was indeed developed privately by Paul Fisher, who invested his own company's money into the project. He created a pen with a pressurized ink cartridge that could write upside down underwater in extreme temperatures and, crucially, in the vacuum of space. NASA tested the pen rigorously for over a year and then decided to purchase them for the Apollo missions. The Soviets, recognizing a good solution, also bought the very same pens. So the reality is not a tale of wasteful American engineers versus pragmatic Russians, but one of independent innovation solving a genuine safety concern for both superpowers, who then both adopted the best tool for the job. The space pen was never a symbol of government excess, but a triumph of private enterprise that ended up serving everyone. That lingering silence in space gives way to a different kind of quiet here on Earth, the hushed whispers of one of history's most persistent conspiracy theories. The idea that the Apollo moon landings were an elaborate hoax filmed on a soundstage refuses to die despite a mountain of evidence to the contrary. Let us systematically dismantle this myth with proof that is still being actively used by scientists today. Perhaps the most irrefutable piece of evidence is a set of small, unassuming devices left on the lunar surface by the Apollo 11, 14, and 15 crews. These are called lunar laser-ranging retroreflectors, and they are essentially sophisticated arrays of corner cube mirrors. Their design is brilliantly simple. They reflect any incoming light beam directly back to its source, no matter the angle. For over 50 years, observatories on Earth have been firing powerful laser pulses at these precise locations on the moon. They then measure the exact time it takes for the faintest glimmer of that light to return. This is not a theoretical exercise. It is a routine experiment that provides invaluable data on the moon's orbit, its gravitational field, and even tests fundamental physics. If those retroreflectors were not actually on the moon, these consistent, measurable results, which require a round-trip distance of nearly 500,000 miles, would be utterly impossible to achieve. No studio effect could replicate this ongoing, long-distance conversation between our world and the moon. Then there is the matter of the moon rocks themselves. The Apollo missions brought back 842 pounds of lunar material, a treasure trove that has been shared with scientists around the globe. These are not just ordinary rocks from some desert on Earth. Their composition is utterly unique, formed in an environment completely devoid of water and oxygen. They contain isotopes and minerals that match the conditions of intense meteoroid bombardment and volcanic activity specific to the moon's history. Crucially, they are completely distinct from any meteorites found on Earth, including those believed to be of lunar origin. The Soviet Union's own lunar program also returned a small amount of moon soil in the 1970s, and its chemical signature perfectly matched the Apollo samples, a fact the rival superpower would have been all too happy to expose as a fraud had it been one. The geological evidence is a silent, stony witness that cannot be faked. Finally, we can now simply look and see. In 2009, NASA, a lunar reconnaissance orbiter, began circling the moon, capturing the highest resolution images ever taken of its surface. Its powerful cameras have photographed every single Apollo landing site in stunning detail. These are not vague, blurry shapes. The images clearly show the descent stages of the lunar modules, sitting exactly where they were left decades ago. You can see the paths of the astronauts' footprints, tracing their routes between the lander and various experiment packages. You can even make out the rovers from the later J missions, looking like tiny, parked cars on the gray, dusty plains. These are not artifacts or tricks of the light. They are the indelible marks of human exploration, preserved in the airless lunar environment for anyone with a satellite to observe. Every piece of evidence, from the lasers we fire to the rocks we hold to the tracks we can still see, forms an unbreakable chain of truth. The real story of how we reached the moon is far more extraordinary than any fiction designed to explain it away. Logic dictates that the planet closest to the sun should also be the hottest, a title that seems to belong to Mercury. Yet this seemingly obvious fact is completely wrong. Mercury, despite its close orbit, is not the solar system's hottest planet. That scorching crown is held by Venus, the second planet from the sun, a world that demonstrates how a planet's atmosphere can completely rewrite the rules of temperature. Mercury is a barren, airless rock, With no significant atmosphere to speak of, it has no blanket to trap the sun's intense heat. During its long day, when one side is facing the sun for months at a time, surface temperatures can indeed soar to a searing 800 degrees Fahrenheit. But that same lack of an atmosphere means there is nothing to hold onto that thermal energy when the planet rotates into the darkness of its night. The heat radiates away into the void almost instantly, and temperatures plummet to a bone-shattering negative 290 degrees Fahrenheit. This is the most extreme temperature swing in our entire solar system, a daily cycle between a furnace and a deep freeze. Venus, on the other hand, presents a far more consistent and terrifying picture. Its surface is permanently shrouded by a thick, suffocating atmosphere, one that is over 90 times denser than Earth's and composed almost entirely of carbon dioxide. This creates the ultimate runaway greenhouse effect. Sunlight passes through the dense clouds and heats the surface, but when that surface tries to radiate the heat back out as infrared radiation, the massive blanket of carbon dioxide traps it. The energy has nowhere to go, causing temperatures to build relentlessly. The result is a planetary pressure cooker where the surface temperature remains a constant 860 degrees Fahrenheit, day and night, at the poles and the equator. This is hot enough to melt lead, and it is consistently hotter than even the sunniest spot on Mercury. So while Mercury bakes and freezes in a brutal cycle dictated solely by its proximity to the star, Venus simmers in a perpetual, global inferno created by its own poisonous air. The true ruler of planetary heat is not distance, but the power of an atmosphere gone horribly wrong. Hollywood has trained us to dodge and weave through fields of tumbling space rocks, a chaotic obstacle course straight out of an arcade game. This dramatic depiction of the asteroid belt is another fiction born from cinematic necessity. The reality, as revealed by every spacecraft that has ever journeyed through it, is a profound and almost empty quiet. The asteroid belt between Mars and Jupiter is not a dense, impassable ring of debris. It is a vast, sprawling frontier where loneliness is the rule. Consider the numbers. This belt contains millions of asteroids, which sounds like a terrifyingly crowded neighborhood. But space is immense, and these millions are scattered across a donut-shaped region so colossal it defies human comprehension. The total volume of the asteroid belt is an almost empty void. The average distance between any two significant asteroids is over 1 million kilometers. That is roughly 3 times the distance from the Earth to the Moon. To put it another way, if you were standing on one asteroid, the chance of you even seeing another one with your naked eye, let alone colliding with it, would be virtually zero. When NASA engineers plotted the course for the Voyager probes through the heart of the belt, they were not sweating over a perilous navigation challenge. They were confident they were sending their spacecraft through an enormous, mostly vacant highway. The Dawn mission went even further, spending years orbiting the 2 largest asteroids, Vesta and Ceres. It had to make precise, deliberate maneuvers to reach these worlds, because simply stumbling upon one by accident in that expanse is statistically impossible. The real danger in the asteroid belt is not a constant barrage of collisions, but the sheer difficulty of finding anything at all. This cosmic emptiness shatters the myth of a treacherous debris field, revealing a silent, orderly system where worlds drift in peaceful isolation. The human body is far more resilient than science fiction would have you believe. We have all seen the horrifying cinematic moment where an astronaut's suit fails and they burst apart in a gruesome explosion. This visual is pure fiction, a dramatic shortcut for storytelling that ignores the remarkable strength of our own biology. Your skin is an incredibly tough and flexible organ, a suit of armor you were born wearing. It is more than strong enough to withstand the pressure difference between your body and the vacuum of space. You would not explode. Instead, you would experience a bizarre and terrifying process known as ebulism. In the absence of external pressure, the fluids on the surface of your body, like the saliva on your tongue and the moisture in your eyes, would begin to boil. Not from heat, but from the sudden drop in pressure, much like water boiling at a much lower temperature on a high mountain peak. Your body would swell, perhaps to twice its normal size, as gases within your tissues expanded, but your resilient skin would hold you together. The real, immediate threat is the lack of oxygen. Within 10 to 15 seconds, the oxygen stored in your bloodstream would be depleted and you would lose consciousness. Your heart would continue to beat for a minute or two, struggling to circulate blood that can no longer deliver vital oxygen to your brain. The actual cause of death in the vacuum of space would be asphyxiation leading to circulatory failure, a silent and chilling end. The cold, which seems like the most obvious danger, would be the least of your worries, taking hours to claim a body that has long since been deprived of air. The universe is hostile not because it tears us apart, but because it patiently waits for the air to leave our lungs. Your own bathroom hides a cosmic misunderstanding that spans the entire globe. A persistent myth claims that toilet water swirls down the drain in opposite directions in the northern and southern hemispheres, all thanks to a grand planetary force called the Coriolis effect. It is a compelling idea, linking the most mundane act to the rotation of the Earth itself, but the reality is far less global. The Coriolis effect is a genuine and powerful force, but it operates on a scale far too large for your sink or toilet to notice. This force arises because the Earth is a spinning sphere, and points at different latitudes move at different speeds. A point on the equator has to travel the full circumference of the planet every 24 hours, while a point near the pole barely moves. This difference in rotational speed causes moving air and water to curve slightly relative to the Earth's surface. It is this force that shapes the rotation of massive weather systems, making hurricanes spin counter-clockwise in the north and clockwise in the south. It guides the vast currents of the oceans over thousands of miles, but for a tiny, fast-moving vortex in your bathroom, the Coriolis force is trillions of times weaker than the other forces at play. The direction your toilet flushes is determined by the design of the basin itself. Most toilets are engineered to flush with a specific directional jet of water to ensure efficiency. The shape of the bowl, the angle of the water inlet holes, and even the residual motion left from the last flush have an infinitely greater influence than the spin of the planet. Scientists have tested this in meticulously controlled experiments, filling large, perfectly symmetrical pools and letting the water settle for days to eliminate any residual motion. Only under these pristine, large-scale conditions can the faint whisper of the Coriolis effect be observed dictating the vortex direction. Your sink drain is no different. Its spin is a matter of chance and construction, not a demonstration of celestial mechanics. So while the Earth's rotation truly does steer storms across continents, it leaves the fate of your bathroom water entirely to local, terrestrial design. Our planet's annual journey around the sun holds a perfectly logical explanation for the seasons, yet we consistently get it wrong. The common misconception is that summer arrives when Earth is closest to its star and winter comes when we are farthest away. This feels intuitive, but it is a complete inversion of the truth. In reality, Earth's orbit is only slightly elliptical, and our distance from the sun changes very little. The real architect of the seasons is something far more subtle and constant, the planet's persistent axial tilt of 23.5 degrees. Picture Earth not as a perfectly upright sphere, but as a spinning top leaning to one side, an orientation it maintains throughout its entire year-long voyage. This fixed tilt is the crucial factor. As Earth orbits, the hemisphere that is tilted toward the sun experiences summer. The sun's rays strike that part of the planet more directly, concentrating their energy over a smaller area and delivering more intense heat. Meanwhile, the hemisphere tilted away receives sunlight at a much shallower angle. these slanted rays are spread out over a larger area, delivering less warming power and creating the colder conditions of winter. The most definitive proof of this is a simple calendar check. Earth actually reaches its closest point to the Sun, a position called perihelion, in early January, right in the heart of the Northern Hemisphere's winter. Our planet is millions of miles closer to its heat source during the coldest time of year for half the world. Conversely, we are at our farthest point, aphelion, in early July during the peak of the northern summer. This single fact shatters the distance myth completely. It is not about how close we are to the fire, but which part of the globe is leaning in to feel its warmth. That old adage about lightning serves us well on Earth, but the universe loves to prove our sayings wrong. The idea that lightning never strikes the same place twice is a comforting piece of folklore, yet it is dangerously incorrect. Here on our own planet, lightning has a well-documented preference for tall, isolated structures. The Empire State Building, for instance, is struck by lightning an average of 25 times every single year. It is not a matter of chance, but of physics. Lightning is an electrical discharge seeking the path of least resistance to the ground. A skyscraper, a lone tree, or a radio tower simply provides that most efficient, inviting pathway for the immense charge to follow. If a storm cloud hangs overhead, the same tall object will be struck again and again until the electrical imbalance in the atmosphere is neutralized. This earthly phenomenon is not unique to our world. We have found even more dramatic lightning shows elsewhere in our solar system, rewriting our understanding of where and how electrical storms can form. The gas giant Jupiter is home to tempests of a scale we can barely comprehend. Its turbulent atmosphere, swirling with clouds of ammonia and water, generates lightning strikes so powerful they could dwarf the most intense superbolts ever recorded on Earth. Data from spacecraft like NASA's Juno probe has detected these colossal discharges. The lightning on Jupiter is not confined to water clouds like on Earth. It also flashes deep within towering clouds of ammonia, suggesting a storm dynamics far more complex than our own. These are not simple flashes, they are continent-sized explosions of light in a hydrogen-helium sky. This cosmic perspective shatters the myth completely. Lightning is a fundamental physical process, a universal method of balancing electrical charge. It will always seek out the most efficient route, whether that is a skyscraper on Earth or a vast, rising plume of gas in the Jovian atmosphere. The conditions that create it are repeated wherever atmospheric turmoil exists. So the next time you see a flash illuminate a familiar city skyline, remember that the same raw power is at work on distant worlds, proving that some forces are truly universal, and they have no qualms about visiting the same spot twice. The same force that pins your feet to the ground is the very reason astronauts float inside the International Space Station. We label this sensation zero gravity, but that term is a complete misnomer. The environment aboard the station is more accurately described as microgravity, a state of continuous freefall that creates the perfect illusion of weightlessness. Gravity has not vanished, it is working exactly as intended. The station is hurtling around Earth at a breathtaking 17,500 miles per hour. This forward motion, combined with Earth's gravity pulling it inward, creates a stable orbit. Imagine swinging a ball on a string in a wide circle. The tension in the string constantly pulls the ball inward, preventing it from flying away. Now replace the string with gravity and the ball with a football field-sized laboratory. The station is perpetually falling toward Earth, but its tremendous sideways speed means it continuously misses the horizon, tracing a circular path around the planet. Everyone and everything inside is falling at the exact same rate, so there is no relative force pushing them against a floor or a wall. They are all in the same state of accelerated motion, which feels identical to having no gravity at all. This principle extends far beyond our orbit. Gravity is the master architect of our solar system. the invisible hand that keeps moons circling planets and planets circling the sun. Without its persistent pull, the station would fly off into the void and the orderly dance of the cosmos would collapse into chaos. The universe is not a gravity-free zone. It is a realm where falling can feel like flying. A full moon's glow has long been blamed for turning sane minds toward madness. This belief, sometimes called the lunar effect, suggests that emergency rooms overflow, crime rates spike, and birth wards become unusually busy under its silvery light. Yet decades of rigorous scientific investigation have found this connection to be a complete illusion, a phantom correlation sustained by the tricks our own minds play on us. Researchers have conducted massive meta-analyses, poring over thousands of hospital admission records, police reports, and birth statistics spanning many years. The results are unequivocal. There is no statistical uptick in human turmoil that aligns with the lunar cycle. Birth rates do not synchronize with the moon's phases, nor do admissions for psychiatric emergencies or acts of violence. So why does this myth feel so true to so many? The answer lies in a powerful cognitive trap known as confirmation bias. Our brains are wired to notice and remember events that confirm our pre-existing beliefs, while simultaneously filtering out and forgetting all the evidence that contradicts them. If you work a busy Friday night in an emergency room and you believe the full moon brings chaos, you will vividly remember the night it was packed and the moon was full. You are far less likely to notice or later recall the many other equally chaotic nights when the moon was a mere sliver or hidden by clouds. The quiet, peaceful full moon nights simply do not register in your memory because they do not fit the expected pattern. This selective memory creates a compelling but entirely false narrative. The myth persists not because of any gravitational or mystical pull from our celestial neighbor, but because of the gravitational pull of our own flawed perception, drawing random events into a story that feels true. The real mystery is not the moon's power over us, but our own power to see patterns where none exist. Mars holds a monument to our own imagination. In 1976, NASA, a Viking 1 orbiter, was mapping the planet's Cydonia region when it snapped a photograph that would ignite decades of speculation. The image was grainy and low resolution, but it seemed to show a colossal humanoid face staring up from the rusty landscape, complete with what appeared to be eyes, a nose, and a mouth. The idea of an ancient alien monument, a sphinx of another world, captured the public consciousness and refused to let go. It was the perfect cosmic mystery, a story begging to be told. But science, armed with better technology, eventually returned for a closer look. Decades later, the Mars Global Surveyor and other modern orbiters flew over the same spot, their high-resolution cameras capturing the truth in stunning detail. The so-called face was not a sculpted artifact at all. It was a completely natural mesa, a large butte worn down by millions of years of Martian wind and erosion. The new images showed a rugged, rocky hill, its features scattered with boulders and gullies. The symmetrical eyes were shadows cast by sun hitting a central peak, the nose a trick of the light on a sloping hillside, and the mouth a simple collapse feature. The illusion that had seemed so compelling in the blurry Viking photo evaporated completely under the cold, clear gaze of a better camera. This phenomenon that fooled us has a name: pareidolia. It is the hardwired human tendency to see familiar patterns, especially faces, in random stimuli. We see the man in the moon, a rabbit in the clouds, or the Virgin Mary on a piece of toast. Our brains are expert pattern recognition machines, constantly scanning our environment to identify potential threats, friends, or food sources. This skill was essential for our survival, but it comes with a side effect. We often find meaningful shapes where none actually exist. The face on Mars was a perfect storm of pareidolia, combined with the limited technology of its time. The low-resolution image provided just enough ambiguous detail for our brains to fill in the blanks and construct a recognizable face from a jumble of rocks and shadows. It was not a lie, but an interpretation, a story we told ourselves about a landscape we could not yet see clearly. The real monument on Mars is not a carved face, but a testament to the power and occasional pitfalls of human perception itself. Our own pattern-seeking brains naturally crave a center, a focal point from which everything else radiates. We look at a galaxy and find its core. We examine a solar system and pinpoint its star. So it feels almost instinctive to ask, where is the center of the universe itself? The answer is a profound one that challenges our deepest intuitions. The universe has no center. This is not because we have not found it yet, but because the very nature of cosmic expansion makes a single, central location impossible. To understand why, we need to reimagine the Big Bang not as a traditional explosion in space, but as the sudden emergence of space itself, everywhere at once. Picture the surface of a balloon as you slowly inflate it. Glue several small dots onto the rubber. As you blow more air into the balloon, each dot moves away from every other dot. Now, from the perspective of any single dot, it appears to be at the center of the expansion because all the other dots are receding from it. But here is the crucial point: the surface of the balloon has no center. You cannot point to one spot on that stretching rubber and declare it the middle of the expansion. The universe we inhabit is analogous to that entire surface, but in 3 dimensions. This is the core of the cosmological principle, a fundamental idea in modern astronomy. It states that on the very largest scales, the universe is both homogeneous and isotropic. Homogeneous means the universe has a roughly uniform distribution of matter and energy. It looks the same no matter where you are. Isotropic means it looks the same in every direction you look. There are no privileged locations, no grand central headquarters for the cosmos. From our vantage point on Earth, every distant galaxy is rushing away from us, and the farther away it is, the faster it seems to be receding. But an alien astronomer in a galaxy 10 billion light-years away would see the exact same thing, with every other galaxy, including our own Milky Way, fleeing from them. Every point truly is the center of its own observable universe. This is why the question of a universal center is a myth, a relic of our earthbound perspective trying to apply local rules to the entire cosmic canvas. The real center is not a place you can travel to. It is a perspective, a fundamental property of the fabric of reality that grants every observer the same dizzying central view. That same sensation of weightlessness astronauts experience in orbit can be briefly created right here in Earth's atmosphere. NASA's famous Vomit Comet, a specially modified aircraft, does not simulate the vacuum of space at all. Instead, it performs a carefully choreographed aerial maneuver known as a parabolic flight. The pilot puts the plane into a steep, powerful climb, pushing the occupants down into their seats with force. Then, at the peak of the arc, the pilot reduces thrust and lets the aircraft essentially fall back toward Earth, tracing a graceful parabola through the sky. For about 20 to 30 seconds, everyone and everything inside the plane is in a state of freefall. Since the craft is falling at the same rate as the people within it, there is no force pinning them to the floor, creating the perfect illusion of microgravity. It is the exact same principle that keeps the International Space Station in perpetual freefall around the planet, just on a much smaller, shorter scale. The nickname Vomit Comet is a testament to how disorienting this feeling can be, as the body's vestibular system struggles to make sense of the sudden lack of up and down. These flights are not about experiencing emptiness, they are a vital training ground. Astronauts use these precious moments of weightlessness to practice maneuvering their bodies, handling tools, and conducting simple experiments before they ever leave the planet. It is a rehearsal for the real performance, a way to learn how to move and work in an environment where the usual rules no longer apply. The plane does not cancel gravity, it simply uses gravity's own pull to teach us how to float. Our cosmic origin story is often misunderstood as a single, cataclysmic detonation. We picture a primordial fireball erupting in a dark, empty void, flinging matter outward like shrapnel from a cosmic bomb. This mental image is compelling, but it is fundamentally wrong. The Big Bang was not an explosion in space, it was the explosive emergence of space and time themselves. There was no pre-existing emptiness for the universe to expand into, because the very concepts of outside and inside did not yet exist. Everything we know, every particle of matter and every ripple of energy, was contained in an unimaginably hot, dense state, often described as a singularity. Then, space itself began to swell at a rate beyond comprehension, carrying the nascent universe with it. A helpful way to visualize this is to think of the surface of a balloon. Glue a few small paper dots onto the rubber to represent galaxies. Now, as you inflate the balloon, each dot moves away from every other dot. Notice that no single dot is the true center of this expansion on the two-dimensional surface. The dots are not traveling across the balloon, they are being carried apart by the stretching of the fabric itself. Our three-dimensional universe is analogous to that entire expanding surface. Every galaxy cluster is moving away from every other because the space between them is continuously growing. This is why astronomers observe that the farther away a galaxy is from us, the faster it seems to be receding, a key prediction of this model. The Big Bang did not happen at one point in space, it happened everywhere at once. It is the reason the cosmos has no center and no edge, a concept that challenges our deepest instincts but is supported by overwhelming evidence. We are not flying away from the site of some ancient blast. We are part of the still stretching fabric of that initial event, riding a wave of expansion that began nearly 14 billion years ago. The gentle twinkling of a star is a celestial lullaby, a dance of light we have romanticized for millennia. Yet that beautiful shimmer is not a property of the star itself, but a flaw in our own planetary window. Stars twinkle, a phenomenon scientists call scintillation, because their light must pass through the turbulent ocean of our atmosphere before it reaches our eyes. Imagine the air above you is not a calm, transparent sheet of glass, but a raging, invisible river. It is filled with pockets of warm and cool air, each with a slightly different density. As the pinpoint of light from a distant star travels through this chaotic maze, it gets bent and refracted, jostled in countless tiny directions. To your eye, this constant, rapid shifting makes the star appear to flicker and change color, dancing in its place in the sky. Planets, however, tell a different story. While they may appear as points of light to the naked eye, they are actually much closer to us and present as tiny, resolved disks in the sky. This makes all the difference. The light from one edge of the disk might be bent one way, while light from the opposite edge is bent another. These effects average out, creating a much more stable and steady glow. The planet's light is not a single, vulnerable pinpoint, but a collective beam that resists the atmosphere's distortions. For the ultimate proof, we must leave our atmosphere behind. Astronauts in orbit witness a sky utterly transformed. Unfiltered by the blanket of air, the stars do not twinkle at all. They burn as unwavering, steady points of brilliant light, their true, constant nature finally revealed. The romantic twinkle is not a greeting from the star, but the signature of our own restless world, a reminder that we are always looking up through a storm. The romantic stillness of the cosmos is another grand illusion. We picture the void between stars as a perfect, absolute emptiness, a sterile nothingness awaiting human arrival. This could not be further from the truth. What we call empty space is actually a very thin but incredibly active sea known as the interstellar medium. It is not a true vacuum, but rather a diffuse soup of gas and dust. The primary ingredient is hydrogen gas, with a single atom floating in a volume of space about the size of a typical household closet. Alongside this gas are tiny solid particles, grains of dust smaller than a wavelength of light, made of carbon and silicon. This medium is also crisscrossed by magnetic fields and flooded with cosmic rays, which are high-energy particles, mostly protons, racing across the galaxy at nearly the speed of light. These particles are so energetic they can penetrate spacecraft hulls and pose a radiation risk to astronauts. If you could shrink down and travel through this so-called void, you would find yourself in a faint, flowing nebula of matter and energy. But the true masters of this cosmic ocean are the components we cannot see or touch directly: dark matter and dark energy. Dark matter is an invisible form of matter that does not emit or absorb light, yet its gravitational pull is the only thing holding fast-spinning galaxies together. Without its unseen grasp, stars would be flung off into the intergalactic darkness. Then there is dark energy, an even more mysterious force that seems to be woven into the fabric of space itself, causing the expansion of the universe to accelerate. These two invisible entities make up over 95% of the total mass and energy content of the cosmos. The ordinary matter that builds stars, planets, and us is just a mere 4% garnish on a vast, dark, and dynamic universe. The emptiness of space is a profound misconception. We are not sailing through a vacant sea, but swimming in a deep, mysterious ocean whose strongest currents are completely invisible to our eyes. The North Star's fame is built on a fundamental misconception. It is not the brightest beacon in our night sky, but rather a steady, moderate light ranked only as the 48th brightest star we can see. Its true value has nothing to do with its brilliance and everything to do with its unique address in the cosmos. Polaris sits almost directly above Earth's North Pole, a fixed point around which the entire northern sky appears to slowly rotate. While other stars wheel through the darkness, tracing great arcs from east to west, the North Star remains virtually motionless, a constant sentinel in the north. This is why it has been an indispensable guide for centuries for ancient mariners, explorers, and even lost hikers today. Finding Polaris means you have found true north, providing an unchanging reference in a turning world. If you seek true stellar luminosity, look to Sirius, the dog star, which outshines every other star in our sky with a blazing white intensity. Or look south to Canopus, the second brightest star, a brilliant yellow-white giant that dominates the southern hemisphere. These are the real powerhouses of our galactic neighborhood. Polaris is not the king of the stars, but the most reliable signpost in the heavens, a lesson that sometimes the most important guide is not the loudest, but the one that never moves. That myth of the Great Wall's visibility becomes even more fantastical when we push the vantage point all the way to the moon itself. If spotting it from Earth orbit is a challenge, then seeing it from 250,000 miles away is an absolute impossibility. The astronauts who have actually walked on the lunar surface are the ultimate witnesses, and their testimony is unanimous. Not a single Apollo crew member from any of the 6 missions that landed there ever reported seeing any human-made structure from the moon. Not the Great Wall, not sprawling cities, not even the vast glowing networks of our nighttime lights. The entire tapestry of human civilization simply vanishes at that distance. The only human artifact visible from the lunar surface is the one you are standing next to, the lunar module itself, a tiny metallic speck against an endless gray landscape. The Earth hangs in the black sky as a beautiful, swirling marble of blue and white, a stunning oasis of life, but you cannot pick out any details of our works. The scale is simply too immense. Think of trying to see a single human hair from nearly 2.5 miles away. That is the equivalent angular size challenge of spotting the Great Wall from the moon. Our eyes, remarkable as they are, have a finite resolution. The wall's width, when viewed from that distance, shrinks to a fraction of a single arcsecond, far below the threshold of human visual perception. It would be like trying to distinguish a single grain of sand on the beach while looking at the entire coastline from an airplane. The cosmos constantly reminds us of our physical smallness, not through malice, but through the simple, unyielding laws of optics and scale. The real wonder is not that we can see our creations from the heavens, but that we can look back at our fragile, isolated world and understand our true place in the vastness. The journey to the moon required navigating a celestial minefield we never see from Earth, the Van Allen radiation belts. These vast, donut-shaped zones of intense radiation surrounding our planet have often been portrayed as an impassable, fatal barrier for human spaceflight, a ring of fire that should have cooked the Apollo astronauts. This fear misunderstands both the nature of the belts and the cleverness of the mission planning. The Van Allen belts are not a solid, uniform wall of death. They are regions where Earth's magnetic field has trapped high-energy charged particles from the solar wind. There are two main belts, an inner and an outer one, with a slot region of significantly lower radiation between them. NASA engineers did not simply aim the spacecraft straight through the most intense parts. Instead, they meticulously charted a trajectory that exploited this very slot, a path that minimized the astronauts' time in the most hazardous zones. The Apollo capsules were launched on a trajectory that took them through the thinnest, least active regions of the belts, and they were moving at such tremendous speed that the entire transit lasted only about an hour. The spacecraft hull itself provided substantial shielding against this relatively brief exposure. The total radiation dose the crews received was carefully measured, and it amounted to less than what you would get from a single CT scan at a hospital. It was a calculated risk, not a suicidal plunge. This was not a barrier that needed to be smashed through, but a natural obstacle that was understood, respected, and elegantly bypassed. The Van Allen belts stand not as a testament to space's inherent lethality, but to human ingenuity's ability to find a safe path through the storm. The doomsday myth of a rogue planet named Nibiru colliding with Earth resurfaces with every passing anxiety, yet it is a phantom menace with no basis in astronomical reality. This hypothetical world, supposedly lurking in the outer solar system on a deadly trajectory, would be impossible for modern astronomy to miss. Its existence is disproven by multiple, independent lines of evidence that scan the sky every single night. First, consider the gravitational footprint such a massive planet would leave. An object large enough to threaten Earth would have a staggering gravitational pull, one that would severely disrupt the orbits of all the outer planets we have been meticulously tracking for decades. The precise paths of worlds like Neptune, Uranus, and the myriad objects in the Kuiper belt are a perfect cosmic ledger, and their motions show no unexplained anomalies, no hidden hand tugging them off course. The math is unequivocal. The solar system's gravitational balance sheet is perfectly clean. Furthermore, if Nibiru were on an inbound path as predicted, it would already be one of the brightest objects in our sky, a glaring red eye visible to anyone with a simple telescope or even a good pair of binoculars. Professional and amateur astronomers alike would have spotted it years ago. The final, definitive nail in the coffin comes from automated, all-sky surveys like the Pan-STARRS Observatory in Hawaii. These projects are designed to find moving objects precisely to catalog near-Earth asteroids and distant, slow-moving planets. They photograph the entire visible sky repeatedly, night after night, with immense sensitivity. A planet of Nibiru's purported size and proximity would stand out in their data like a lighthouse in a fog, its motion easily tracked and its orbit calculated. The silence from these powerful surveys is deafening. They have found no such object because it simply is not there. The universe presents us with enough genuine mysteries without having to invent celestial disasters that our own tools and telescopes prove cannot exist. That iconic flag, seemingly caught in a lunar breeze, has fueled decades of conspiracy theories. How could it be waving if the moon has no air? The answer is not a mystery of wind, but a triumph of simple, clever engineering and the strange physics of a vacuum. The flag was not designed to hang limply like a curtain. NASA engineers, fully aware of the airless environment, equipped it with a horizontal telescoping rod sewn into the top hem. This rod was intended to hold the flag outstretched and fully visible, preventing it from drooping straight down in the total absence of wind. When the astronauts planted the flagpole, they struggled to pull the rod completely taut. It remained slightly bent, giving the flag a permanently rippled appearance. The famous waving motion we see in the video footage comes from the astronauts themselves as they twisted and pushed the pole into the tough lunar soil. They were physically manipulating the flagpole, causing the entire assembly to vibrate. In the vacuum, with no air resistance to slow the motion down, these vibrations continued for a surprisingly long time. The lightweight fabric, once set in motion, kept moving back and forth in a slow, pendulum-like fashion. There was no breeze to push it, only the leftover energy from the astronauts' own actions, playing out in a silent, frictionless dance. The flag's crumpled shape is also a permanent monument to that moment. On Earth, gravity would eventually pull the fabric smooth, but on the Moon, with no air molecules to nudge it and only weak gravity, the creases and ripples imposed by the rod and the astronauts' handling are frozen in time. That flag is not waving in the wind, it is caught in a single, extended moment of human activity, a motion preserved forever in the still, silent airlessness of the lunar surface. A crimson moon hanging in the night sky has signaled impending doom for countless cultures across human history. This so-called blood moon was seen as a portent of disaster, a divine warning written in light across our celestial companion. The reality is not a sign of cosmic anger, but a breathtaking demonstration of celestial alignment and the gentle filtering of our own planet's light. The phenomenon is a total lunar eclipse, a predictable event that occurs when the Earth moves directly between the Sun and the Moon. The Moon does not go completely black because sunlight skims the edge of our world, passing through the blanket of our atmosphere. Our air acts like a giant global prism, scattering the shorter blue wavelengths of light and allowing the longer red and orange wavelengths to bend or refract around the curve of the planet. This process casts a soft, coppery glow onto the lunar surface, painting it with the combined light of every sunrise and sunset happening on Earth at that very moment. Ancient civilizations, lacking our orbital mechanics, understandably viewed this sudden, dramatic change with awe and fear. The Mayans believed a jaguar was devouring the moon, while Mesopotamian cultures saw it as an assault by demons. These stories were humanity's first attempts to explain a universe they did not yet understand. Today, we can calculate lunar eclipses with pinpoint accuracy centuries in advance, knowing they are nothing more than the precise clockwork motion of our solar system. The blood moon is not an omen of chaos, but a beautiful reminder of cosmic order, a shared sunset reflected 250,000 miles away. This persistent myth about weightlessness stems from a deep confusion between the absence of gravity and the absence of its effects. The force of gravity is what makes the entire cosmic dance possible in the first place. Think of it this way: every single object in orbit is perpetually falling. The International Space Station is falling directly toward Earth's center, pulled by an unbreakable gravitational tether. Yet it never gets any closer to the surface because it is also moving sideways at an incredible 17,500 miles per hour. The planet's curvature drops away beneath it at the exact same rate the station falls. This creates a perfect, endless balance, a state of continuous freefall where the object is accelerating toward the planet, but its forward velocity ensures it constantly misses the ground. This elegant principle was famously illustrated by Isaac Newton's cannonball thought experiment. Imagine firing a cannon horizontally from a mountaintop. The cannonball will arc toward the ground, landing some distance away. Fire it faster and it lands farther away. Now, imagine you could fire it with such immense speed that as it falls, the Earth's surface curves away beneath it at the same rate. The cannonball is still falling, but it is falling around the planet, becoming a tiny moon. That is precisely what an orbit is, a controlled, high-speed fall that never ends. The sensation of weightlessness inside the station is not because gravity has vanished. It is because the station and everyone inside it are all accelerating at the same rate. There is no floor pushing up against your feet to provide that familiar feeling of weight, which physicists call the normal force. You are falling, the floor is falling, and your coffee is falling all together. This is the essence of Einstein's equivalence principle, which states that the effects of gravity are locally indistinguishable from the effects of acceleration. The experience of floating in the station is identical to the experience you would have inside a windowless elevator car that was being accelerated through empty space by a rocket. In both cases, you feel weightless because you are in a state of freefall, not because you are beyond gravity's reach. The universe is not a place without gravity. It is a place where falling can feel exactly like flying. Our final cosmic myth is perhaps the most profound, a question that echoes back to the very beginning. We might assume the universe is only as old as its eldest stars, but this confuses the age of the inhabitants with the age of the house itself. The most ancient stars we can observe, nestled within globular clusters, are indeed venerable, with ages calculated at over 13 billion years. Yet, the cosmos itself is older still, clocking in at approximately 13.8 billion years. How can we possibly date something so vast and ancient? The answer is written across the entire sky in a faint, cold glow known as the cosmic microwave background. This is the remnant heat from the Big Bang, the afterglow of creation itself, cooled and stretched by the expansion of the universe into a uniform microwave signal that permeates all of space. By mapping the subtle fluctuations in this background radiation with incredible precision, satellites like Planck have given us a baby picture of the infant universe from which we can calculate its exact age. Another critical measurement comes from the Hubble constant, the rate at which the universe is expanding. By precisely measuring how fast galaxies are receding from us, we can effectively run the cosmic film backward to determine when everything was compressed into that initial hot, dense state. Both of these independent methods converge on the same number, 13.8 billion years. This timeline makes perfect sense. The universe needed time to cool and expand after the Big Bang before the first clouds of hydrogen and helium could collapse under gravity to ignite the very first stars. The oldest stars are not the universe's contemporaries, they are its firstborn children, shining their light from a darkness that existed long before their nuclear fires ever sparked to life. We have journeyed through a cosmos cleansed of fiction, replacing Hollywood spectacle with the quiet power of scientific truth. From the silent vacuum to the misunderstood nature of black holes, the real universe has proven itself far more strange and wonderful than any myth we could invent. This process of discovery and correction is the very heart of science, a continuous journey of questioning, testing, and refining our understanding. It is a reminder that our knowledge is not a set of carved stone tablets, but a living, breathing map that we redraw with every new observation. The greatest wonder is not in the falsehoods we once believed, but in our own capacity to look up at the stars and relentlessly seek the real story behind the light. The next great cosmic mystery is waiting to be unraveled, perhaps by a question forming in your own mind right now. What other widely held space myths have you encountered? Share your favorites in the comments below. And if this journey through the real cosmos has reshaped your view of the universe, be sure to like this video, subscribe for more deep dives into the fabric of reality, and join us as we continue to explore the final frontier, one truth at a time.